Okay, my friends, so what you see here are the two data sets I collected. You got the thumb times up top and the finger times down below for each of 15 students that were in class the day I ran this experiment. So 6 data points for each student. I have all the thumb times at the top, even if they did the thumb time second, and all the finger times at the bottom, even if they did their finger times first. Remember, I had to flip the penny to decide which one they did first. But then to organize the data, I put them together like this. Okay, now one way you could do this, I wouldn't, but one way you could do this is you could form a confidence interval around those thumb times using the thumb times and the standard deviation of that average and the sample size. And you could form a confidence interval of the finger times using the average, standard deviation, and sample size of the finger times. And then you could check to see if those two confidence intervals overlapped. Now, there's 2 reasons I don't like that. First of all, I don't like using multiple confidence intervals because of the discussion we had last week or the week before about the lack of confidence you end up running when you do that. Every time you add another confidence interval at only 95% confidence, your confidence actually drops. So one way to control that, of course, is to make the interval wider by increasing the confidence on each interval. But that's overkill. That makes the interval wider than it has to be. That's the first reason I don't like doing it. The second reason I don't like doing it that way makes it seem like you've got almost 45 data points. You don't. You have 15 students. Check this out. These 2 data sets are tied together by student 1. I shouldn't really be comparing student 1 to the entire group independently on the thumb times and independently on the finger times. I want to compare student 1 to student 1. I want to see how student 1 did with his thumb times compared to his finger times. So what I'd like to do is I'd like to actually take the difference of the thumb times and the finger times and see what that is. Now, the problem with that, of course, is I've got 3 different thumb times and 3 different finger times. Whenever I'm in a situation like this, dear friends, where I've got multiples and I've got 2 different sets that I need to subtract, you have a choice. One thing you can do is you can take the average of the 3 values here and then put that here. I tend to rely more on the median than the average. Although they're very often close, I just can't help when I was scanning the data just now, when I was looking at the data, I see a lot of 22s and 23s, which kind of correspond to the times that were in that film, if you remember. But then way over here, I happen to notice this student 15 over here had a time of 15 for some reason. And this one had a time of 26. So we've got some kind of weirdness going on here as far as the times go. If we use the average, those kind of outlier data points might actually skew our average a little bit. So you know what I'm going to do? I'm going to do the median. So I'm going to do the median thumb time. Let's make that font smaller so I can actually fit it in that cell. Take that. Okay, so I'm going to use equals median. All right, and I'm going to select these data points. Okay, that's the median of these 3 data points, and then I'm going to drag that command all the way over here. So that way, since the median is a non-computational measure of center, it won't be affected by the outliers as much. Now, of course, they had a couple students here that missed a time, and that's okay too, because the median just grabs whatever time is between the 2 that they had. Very good, very good. All right, let's do the exact same thing down here, but with the finger time. Okay. Equals median. Okay. And then drag that sideways. There we go. Very nice, very nice. Okay. Now, we've got the median thumb time from student 1 and the median finger time from student 1. I propose we look at the difference of their thumb and their finger. So I go thumb minus finger. That the difference here is negative 0.1 because their thumb time was a little bit faster, 1/10 of a second faster. The negative is telling us that the thumb was a smaller number than the finger. And I'm going to drag that sideways. All right, let's take a look at this data as we drag. Very nice, very nice. A couple things that jump out at me. Number 1, I see some negatives. There's definitely some negative data points, meaning the thumb was faster than the finger. Very nice. I also see some positives. which means the finger was faster than the thumb on those students. And I see this 1-0 over here at student 11. Very cool. That's actually rad. If you look at their data sets, I didn't even notice that till right now. They're identical except for the 23, the 23.1. God, I love random numbers. So cool. Okay, now, that, my dear friends, right here, that is the data set I'd like to analyze, because that right there, in my humble opinion, is the exact representation of what the parent was saying at Doug's swim meet. Is there a difference between the thumb and the finger times per person? Let's go take a look.